In this lesson, we will delve into the field of machine learning. We will discuss the different types of machine learning, including supervised and unsupervised learning. We will explain the differences between these types of machine learning and the strengths and weaknesses of each. We will also explore the various applications of machine learning in areas such as personalization, predictive analytics, and anomaly detection. We will discuss how these tools can be used to improve efficiency and productivity in various settings. You will learn how to use machine learning libraries such as Scikit-learn, TensorFlow, and PyTorch to train models and gain insights. Machine learning, ML, is a subset of artificial intelligence, AI, that focuses on the development of algorithms and models that enable systems to learn from data and make predictions or decisions without being explicitly programmed. The goal of machine learning is to enable machines to learn from data, identify patterns, and make decisions with minimal human intervention. There are several types of machine learning, including supervised, unsupervised, semi-supervised, and reinforcement learning. Supervised learning. In supervised learning, the system is trained on a labeled dataset, where the desired output is provided for each input. The system learns to map inputs to outputs and makes predictions for new, unseen data. The main advantage of supervised learning is that it can be used to make predictions with a high degree of accuracy. It's also relatively easy to understand and implement. However, the model's performance is dependent on the quality and representativeness of the training data, and it may not generalize well to new, unseen data. Examples of supervised learning include linear regression, logistic regression, and support vector machines, SVMs. Unsupervised learning. In unsupervised learning, the system is not provided with labeled data and must discover the underlying structure of the data on its own. Unsupervised learning methods are used to identify patterns or relationships in the data. The main advantage of unsupervised learning is that it can be used to find patterns in data that are not immediately obvious. It's also useful when labeled data is not available or too expensive to acquire. However, the output of unsupervised learning methods may be harder to interpret, and the model's performance can be affected by the choice of the algorithm and the parameters used. Examples of unsupervised learning include clustering, dimensionality reduction, and anomaly detection. Semi-supervised learning. In semi-supervised learning, a small amount of labeled data is combined with a large amount of unlabeled data to learn the underlying structure of the data. This type of learning is useful when labeled data is scarce or expensive to acquire. The main advantage of semi-supervised learning is that it can be used to make predictions with a high degree of accuracy, even when labeled data is scarce. However, the model's performance can be affected by the choice of the algorithm and the parameters used. Reinforcement learning. In reinforcement learning, the system learns from interacting with the environment and receives feedback in the form of rewards or penalties. The goal of reinforcement learning is to learn the best sequence of actions to maximize the cumulative reward over time. The main advantage of reinforcement learning is that it can be used to learn decision-making policies and to optimize control systems. However, it requires a lot of data and can be computationally expensive. Additionally, it can be hard to define an appropriate reward function that will guide the agent to learn the desired behavior. In summary, supervised learning is useful for classification and regression tasks, unsupervised learning for clustering and dimensionality reduction, semi-supervised learning for tasks where labeled data is scarce, and reinforcement learning for decision-making and control tasks. Each type has its own strengths and weaknesses, and the choice of the type of learning depends on the problem you're trying to solve and the available data. Personalization. Machine learning can be used to personalize recommendations, such as product recommendations for e-commerce websites, news recommendations for news websites, or movie recommendations for streaming platforms. For example, collaborative filtering, a technique used to make personalized recommendations, is based on the idea that people who have similar preferences in the past will have similar preferences in the future. Machine learning-based personalization systems can be used to improve the customer experience by providing more relevant and targeted recommendations. Personalized recommendations can increase customer engagement, reduce the number of clicks needed to find relevant products, and increase conversion rates. This can lead to increased sales, customer retention, and overall efficiency in the e-commerce industry. Predictive analytics. Machine learning can be used to make predictions about future events, such as stock prices, customer churn, or equipment failure. Machine learning models can be trained on historical data and used to make predictions about future events. For example, time series forecasting, a technique used to predict future values based on historical trends, is commonly used in finance, economics, and other fields. Machine learning-based predictive analytics systems can be used to improve efficiency in various settings by forecasting future trends, identifying potential problems, and providing actionable insights. For example, predictive maintenance in manufacturing can help to identify equipment that is likely to fail, allowing for proactive maintenance, which can reduce downtime, improve productivity, and reduce costs. In finance, predictive analytics can be used to identify potential fraud, reducing the number of false positives and increasing the number of true fraud cases. Anomaly detection. Machine learning can be used to detect anomalies, such as fraud, in financial transactions, network intrusions, or other types of data. Anomaly detection techniques can be used to identify patterns in data that deviate from the normal behavior. For example, one-class SVM, a technique used for anomaly detection based on support vector machines, is commonly used in intrusion detection. Machine learning-based anomaly detection systems can be used to improve efficiency in various settings by detecting unusual patterns in data, which may indicate a problem or an opportunity. For example, in the manufacturing industry, anomaly detection can be used to identify faulty products, reduce the number of defects, and increase the overall quality of the products. In healthcare, anomaly detection can be used to identify patients who may be at risk of developing a particular condition, allowing for early intervention, which can improve patient outcomes and reduce costs. In summary, machine learning can be used to improve efficiency and productivity in various settings by providing personalization, making predictions, and identifying anomalies. Personalization can improve the customer experience and increase sales. Predictive analytics can help to identify potential problems and provide actionable insights. And anomaly detection can help to identify problems early, which can reduce costs and improve efficiency.